All right, so this is lesson 3.3. So these are the third sets of notes in chapter 3. So we're still discussing z-score, but we're going to add something called the central limit theorem to our notes. And the central limit theorem says that the larger the sample size, the more normal and less variable the distribution becomes. So we've been doing z-score, but we've been doing it with population data. This isn't going to affect our math a whole lot, but it will slightly alter it. But the key to the central limit theorem is the larger the size of the sample we take, the more normal the graph becomes. The more normal a graph becomes, the less variable the distribution is. So if you look at the first graph, the one on the left, it says MBA ages if the sampling distribution has 10 people. So it's still normal, but you can see it's a little more varied. The age range on the x-axis goes between 22 and 29, with the average being between like 24 and 27, because that's the three highest bars, right? Same data. In the second graph is actually the same data. It's just with the population or a sample size of 35 instead of 10. So if I take a sample size of 35, and 35 is obviously larger than 10. So if I take a sample size of 35, I see that the age range on the x-axis is now between 23 and 28. So that's a smaller window. And I see that the highest bar is clearly between 25 and 26, where on the left, the highest bar was 24 to 25, 25, 26, 26, 27. It had three high bars. So the larger the sample we can obtain, the better the data the better our data becomes. But sometimes we're forced to take a small sample, but the bigger the sample, the better the study. All right, so how does this change? So we still have histograms, but technically the histogram is not of the population now, it's of the sample. So it's called a sampling distribution, but it's still a histogram. So the sampling distribution, the key definition to remember is the mean of the sampling distribution, in theory, should be equal to the mean of the population. So when we start coding and stuff, we'll see that they're slightly different. But remember that we're talking about statistical theory here. And in theory, the mean of the sampling distribution should be equal to the mean of the population. Okay? Keep that in the back of your mind. And since we are taking samples, instead of talking to every member of the population, we understand that when we take a sample, we are accepting some error in the data. So since we're taking samples, there is some error. It's called standard error. And to calculate how much error that we're having with our study, we calculate something called standard error. And to calculate standard error, remember that R looking thing is actually sigma, and it stands for standard deviation. So we take the population standard deviation and we divide it by the square root of the sample size. So remember the R, the sigma, is standard deviation. N is sample size, or the size of the sample. So to find standard error, it's the standard deviation divided by the square root of sample size. All right, so we've got one example. It says, suppose the population has a mean of 75 with a standard deviation of 12. We take a sample of 30 people to estimate if this information is correct. Okay, so the first question is, what should the mean of our sampling distribution be? So again, on the last slide, we said that in theory, the mean of the sampling distribution should be equivalent to the mean of the population. So if the population has a mean of 75, then we would assume that the sampling distribution would also have a mean of 75, right? Because we assume that the mean of the population is equal to the mean of the sampling distribution. The second question, what is the standard error of the study? So again, standard error is standard deviation divided by the square root of sample size. So my standard deviation is 12. I took a sample of 30 people, so my sample size is 30. So when I find my standard error, again, is standard deviation divided by the square root of sample size. the standard deviation is 12, the sample size is 30, so I just put the numbers where they go, and we type that in the calculator, and we see that the standard error is 2.191. Think of the standard error as the standard deviation of the sampling distribution. So the population has a population mean and a population standard deviation. The sampling distribution has a sampling distribution mean, which again in theory should be equivalent to the population mean. But the sampling distribution's standard error is similar to the standard deviation of the population. But since my sampling distribution should have less variability than the population, and then the larger the sample size, the more normal the data becomes, and the less variable it becomes.